You are small. In fact, calling you small is being generous. To the universe. You, me, and this entire planet barely register at all. We like to think we understand big. A mountain makes us feel tiny. An ocean makes us feel overwhelmed. But here's the kicker. The human brain was never built to grasp real cosmic scale. If you shrank the entire observable universe down to the size of Earth, our galaxy, the Milky Way, would be no bigger than a tennis ball. And Earth would be a single bacterium clinging to its surface. Today, we aren't just looking at stars. We're pushing to the absolute edge of physical existence. Imagine structures so large they laugh at the laws of physics. Distances so extreme that light itself needs billions of years just to cross them. By the end of this, you may feel uncomfortably insignificant, but you'll finally see where we stand in the dark. Before we leave home, we need a reference point. Start with Jupiter. You could fit about 1,300 Earths inside it, and that already feels absurd. But the worst part is, Jupiter is almost meaningless next to the Sun. You could pack 1,000 Jupiters inside our star, which means roughly 1.3 million Earths disappear into it. If you tried to drive a car around the Sun's equator at highway speed without stopping, it would take 5 years to finish one lap. That sounds enormous. But here's the kicker. In the cosmic arena, our Sun is a pebble on a beach. Step out to Sirius, the brightest star in our night sky, twice the Sun's mass and 25 times brighter. And even that is just an opening act. Imagine standing at the mouth of a cave, knowing the real monsters are still deeper inside. Meet Stephenson 2-18. For years, UY Scooty held the crown, but newer measurements knocked it off the throne. Stephenson 2-18 is a red supergiant sitting roughly 20,000 light-years away in the Milky Way's Scutum Centaurus arm. The numbers stop meaning anything here, so picture this instead. If our Sun were replaced by Stephenson 2-18, its surface would stretch beyond the orbit of Saturn, instantly swallowing Mercury, Venus, Earth, Mars, and Jupiter like a cosmic black hole with teeth. Flying around it wouldn't take days or even years. It would take 500 years for a single loop. It's more than 2,000 times wider than the Sun and blasts out hundreds of thousands of times more energy. This star is a dying monster, burning fuel like a fuse already lit, destined to explode. And the most unsettling part, this incomprehensible beast is still just one star. If your brain already feels strained, that's perfect, because we're barely warming up. We haven't even escaped the galaxy yet. If you want to keep pushing into the darkest corners of the cosmos, staying with us matters, because space does not wait. But here's the kicker. What comes next isn't made of light at all. It's made of gravity, and it doesn't care if you're watching. Stars may look impressive, but gravity is the real architect of size. Enter TON 618, not a supermassive black hole, but something far worse, an ultramassive one. It is the heaviest single object ever observed, sitting more than 10 billion light-years away. Imagine 66 billion suns crushed into one point. 66 billion. For comparison, the black hole at the center of our own galaxy weighs only a few million suns, which suddenly feels laughably small. TON 618 makes it look like dust on a lens. Its event horizon stretches nearly 400 billion kilometers across, so wide that light would take weeks just to cross the darkness. Replace our Sun with this object and the solar system wouldn't glow. It would vanish. And surrounding it, a blazing accretion disk shines brighter than 100 trillion suns, acting like a cosmic lighthouse visible from the edge of time. The worst part is, once you cross that boundary, There is no escape, ever. Now we pivot from destruction to creation. Nebulas are the universe's maternity wards, massive clouds where stars ignite into existence. You've probably heard of the Orion Nebula, visible even with simple binoculars, but imagine something far more extreme. The Tarantula Nebula is a monster by comparison, stretching roughly 1,800 light-years across. If it replaced Orion in our sky, it wouldn't be a faint blur. It would dominate the night, covering an area dozens of times larger than the full moon and glowing bright enough to cast shadows at midnight. This is the most violent star-forming region nearby, so energetic that even from the distance of another galaxy, it would still be visible. Inside, radiation from newborn stars tears the gas into towering pillars, like a ruined cathedral frozen in light. Sometimes, size isn't about what exists, but about what doesn't. The universe isn't evenly spread out. It's more like a web, with dense knots of galaxies and enormous stretches of nothing between them. The largest of these voids is called the Boötes void, often nicknamed the Great Nothing. It spans about 330 million light-years across, forming an almost perfect bubble of isolation. Imagine placing our galaxy at its center. We wouldn't have known other galaxies existed until very recently, because the nearest ones would have been too distant to detect for centuries. In a region this large, statistics say there should be thousands of galaxies. Instead, we've found only a few dozen. It's a cosmic ghost town, a reminder that most of the universe is silence, darkness, and empty space waiting between islands of light. Let's put matter back into the darkness. Galaxies hate isolation, so they huddle together in massive clusters, and the heavyweight champion of them all is officially called Call J120 4915, but astronomers gave it a more honest nickname, El Gordo, meaning the fat one. It sits 7 billion light-years away. So we're seeing it when the universe was only half its current age. But here's the kicker. El Gordo isn't one cluster. It's two enormous galaxy clusters slamming into each other at millions of miles per hour. The combined mass is 3 quadrillion times the mass of our Sun. This collision is so extreme that it rips normal matter away from dark matter, exposing the invisible scaffolding of the universe itself. Imagine a slow-motion car crash, except each car contains thousands of galaxies, and the wreckage spans millions of light-years. Zoom out again. Galaxy clusters don't stop there. They link up into even larger structures called superclusters. For decades, we thought we lived in the Virgo supercluster. But the worst part is, Virgo turned out to be just a small neighborhood. In 2014, astronomers realized we are part of something far bigger called Laniakea, which means immeasurable heaven. This structure stretches over 500 million light-years and contains around 100,000 galaxies, including our own. And it isn't random. Imagine a cosmic river. Every galaxy inside Laniakea is flowing, pulled by gravity toward a mysterious region known as the Great Attractor. We are all sliding downhill through space. When mapped, Laniakea looks eerily alive, like the neurons of a colossal brain, complete with filaments, junctions, and voids. And somehow, this half-billion light-year monster is still just our local address. Now we hit the edge of reason. The object that should not exist. The Hercules Corona Borealis Great Wall. This is the largest known structure in the observable universe. It's not a single object, but a colossal wall of galaxies bound together by gravity. How big is it? 10 billion light-years long. Let that sink in. The universe itself is only 13.8 billion years old. Yet light needs 10 billion years just to cross this structure from end to end. Its existence breaks expectations. According to our models, matter should smooth out on scales this large. But this wall refuses to play by the rules. It was discovered by tracking gamma-ray bursts, the most violent explosions ever observed, revealing an unnatural clustering across 10% of the observable universe. Imagine a crack running through reality itself, forcing scientists to question how the universe was even built. Step back far enough, and everything starts to connect. Walls, clusters, and voids snap into a single shape called the cosmic web. This is the universe's skeleton. Invisible filaments of dark matter stretch across space, forming bridges between galaxies. Gas flows along these filaments like traffic on intergalactic highways, feeding massive clusters where the lines intersect. The unsettling part is how organic it looks. Like a sponge, like fungal roots, like a neural network. Some researchers have even noticed mathematical similarities between the cosmic web and the structure of brain cells. Is the universe alive? Probably not in any familiar sense. But it is organized. It is connected. And at this scale, the cosmic web isn't just the largest thing we know. It's everything, woven together into a single, incomprehensible whole. But is it really the end? We're trapped inside the observable universe, a bubble about 93 billion light-years wide, because light beyond that hasn't had time to reach us since the Big Bang. That's our horizon. That's the wall. But here's the kicker. The universe doesn't actually stop there. Most models say it keeps going, possibly forever, stretching beyond anything we can ever touch or measure. And then comes the multiverse idea. Imagine our entire universe as just one bubble floating in an endless cosmic foam, one stitched square on an infinite quilt. If that's true, then everything we've talked about, from our sun to the Hercules Corona Borealis Great Wall, shrinks down to less than an atom in the bigger picture. We're standing on the shore, trying to understand an ocean with a teaspoon. Does that make you feel small? Good. It should. But the worst part would be thinking that means we don't matter. We are the only known pieces of this violent, indifferent universe that can stop and reflect on it. Imagine that. The universe looking back at itself through human eyes. We are stardust that learned how to think. A speck of dust in a sunbeam, surrounded by monsters like Ton 618 and endless voids like Boötes, yet bold enough to measure them, name them, and try to understand them. That isn't insignificance. That's a miracle. If you want to keep exploring this miracle with us, tell us what shook you the most. The black hole, or the void. I'll see you in the comments. Thanks for watching, and keep looking up